Every winter, one brilliant reddish star immediately catches the eye. High within the constellation Orion shines Betelgeuse, one of the largest and most fascinating stars visible without a telescope. For thousands of years it has guided travelers, inspired myths, and reminded humanity that the night sky is constantly changing. Unlike most bright stars, Betelgeuse does not shine with a steady light. Its brightness rises and falls over time, a behavior that ancient observers noticed long before astronomy became a science. Today, powerful telescopes have revealed that these changes are caused by the star itself, a colossal red supergiant whose outer layers are in constant motion. Betelgeuse lies hundreds of light years from Earth, meaning every ray of light we receive began its journey centuries ago. When we look toward Orion, we are not seeing the star as it is today, but as it existed hundreds of years in the past. In many ways, astronomy is the study of ancient light. Although Betelgeuse has a surface temperature much cooler than our Sun, its enormous size makes it vastly more luminous. If it occupied the center of our solar system, its outer layers would stretch beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and the Red Planet. Its scale is almost impossible to imagine. While the Sun is an ordinary star expected to live for around 10 billion years, Betelgeuse was born with many times the Sun's mass. Massive stars live fast and die young. They consume their nuclear fuel at extraordinary rates, exhausting it in only millions of years instead of billions. Deep within its core, hydrogen fusion ended long ago. The star has progressed through successive stages of nuclear burning, producing heavier elements such as helium, carbon, oxygen, neon, and silicon. Each stage occurs under increasingly extreme temperatures and pressures, creating a layered interior similar to the rings of an onion. This complex structure marks the final stages of a massive star's life. Meanwhile, the surface of Betelgeuse is anything but calm. Enormous convection cells, far larger than anything found inside the Sun, carry hot plasma upward before it cools and sinks again. Some of these turbulent regions are so large that they cover a significant fraction of the star's visible surface. As these giant currents shift over time, they cause subtle changes in brightness that astronomers can observe even from Earth. Betelgeuse is also losing mass at an astonishing rate. Powerful stellar winds continuously carry gas and dust away from the star, forming expanding clouds that extend far into surrounding space. Over time, these outflows enrich the galaxy with elements forged inside the star during millions of years of nuclear fusion. Every atom of carbon, oxygen, calcium, and iron created within stars like Betelgeuse eventually becomes part of future generations of stars and planets. Even the elements that make life possible on Earth were produced inside ancient stars that exploded long before our solar system existed. In that sense, Betelgeuse is not simply approaching the end of its life. It is helping shape the future of the Milky Way by returning newly created elements to interstellar space, where they may someday become part of entirely new worlds. Then, in late 2019, something extraordinary happened. Astronomers around the world noticed that Betelgeuse began fading dramatically. Within just a few months, its brightness dropped to a fraction of its usual level, becoming the dimmest it had appeared in modern astronomical history. The event quickly became known as the Great Dimming. Because Betelgeuse is a dying star, many wondered whether the long-awaited supernova had finally begun. For a brief moment, it seemed possible that humanity might witness one of the greatest astronomical. When Betelgeuse dimmed dramatically between late 2019 and early 2020, astronomers around the world immediately took notice. For decades, scientists had known that the star naturally changes in brightness. But this event was different. Betelgeuse faded much more than expected, leading some researchers and countless skywatchers to wonder if the giant star had entered the final moments before a supernova explosion. Observatories across the globe quickly turned their attention toward Orion. Ground-based telescopes monitored the star night after night, while space observatories gathered data across multiple wavelengths of light. Every new measurement helped scientists piece together the cause of one of the most unusual stellar events ever observed. The answer turned out to be remarkable. Rather than exploding, Betelgeuse experienced an enormous outburst from its surface. A massive plume of hot gas was launched into space, carrying an immense amount of material away from the star. As this gas expanded, it cooled rapidly. Tiny dust particles formed within the cloud, creating a temporary veil that blocked part of the star's light from Earth's perspective. At nearly the same time, a large region of Betelgeuse's visible surface became cooler than usual, making the star appear even dimmer. Together, these two events produced the historic Great Dimming. It was the first time astronomers had gathered enough evidence to directly connect a giant surface eruption with the formation of a dust cloud capable of significantly reducing the brightness of a red supergiant. Even after recovering from the event, Betelgeuse continued to surprise researchers. Its cycles of brightening and fading became more complex than expected, suggesting that the outer layers of giant stars are far more dynamic than older models had predicted. Every new observation improves our understanding of how massive stars behave during the final stages of their evolution. Yet the greatest event still lies in the future. Deep inside Betelgeuse, nuclear fusion will eventually reach its limit. As heavier elements accumulate in the core, iron will eventually dominate the center of the star. Unlike lighter elements, iron cannot release energy through fusion. Once enough iron builds up, the delicate balance between the outward pressure from fusion and the inward pull of gravity will collapse. The core will compress in a matter of seconds. Temperatures and densities will rise to extraordinary levels before the collapsing material rebounds, driving a powerful shock wave through the star. The result will be a Type II supernova, one of the most energetic explosions in the universe. For a short time, Betelgeuse may shine with incredible brilliance. Although exact predictions vary, it could become one of the brightest objects in Earth's night sky and might even remain visible during daylight for a period of time. The explosion would likely be observable for weeks or months before gradually fading. Despite its spectacular appearance, there is no reason for concern on Earth. Betelgeuse is located hundreds of light-years away, far beyond the distance at which its supernova would pose a significant threat to our planet. Instead of danger, humanity would witness an extraordinary scientific opportunity unlike anything seen in modern history. Astronomers would study the explosion across the entire electromagnetic spectrum, from radio waves to gamma rays. Detectors designed to observe neutrinos and gravitational waves might also record valuable information, allowing scientists to examine the collapse of a massive star in unprecedented detail. Perhaps the most intriguing mystery is not how Betelgeuse will end, but when. Current research suggests the explosion is likely to occur sometime within the next tens of thousands to around 100,000 years. On cosmic timescales, that is a relatively short interval, but for human civilization, it could still be unimaginably far in the future. There is even an interesting possibility to consider. Because the star is hundreds of light-years away, any event that happens there remains invisible to us until its light reaches Earth. If Betelgeuse were to explode today, observers on our planet would not know until centuries later, when the light from that explosion finally completed its journey across space. Until that day arrives, Betelgeuse will continue shedding its outer layers, enriching the Milky Way with newly created elements. Those atoms will eventually become part of future stars, planets, and perhaps even living organisms somewhere in the galaxy. The story of Betelgeuse reminds us that the universe is built on cycles of transformation. Stars are born from clouds of gas, spend millions of years creating the elements that make planets and life possible, and ultimately return those materials to space through powerful stellar winds and spectacular explosions. In the end, the death of a massive star is not